In recent months, you have probably heard of quantum computers, and you have probably heard that they are a threat to encryption or they can solve huge problems. But not a lot of people actually know what quantum computers are, how they work, and what they can actually do. In this video, I'm gonna try to give a high-level overview of what quantum computers are, how they work, and what problems they can solve. So before we continue talking about quantum computers, we need to talk about classical computers like this one. And we need to talk about how they work, what really goes on under the hood, and it will help us to understand how quantum computers work as well, because they're kind of similar but really, really different. So we are just going to talk about a little bit of classical computing and then move on to quantum computing. So in classical computing, you probably know that zeros and ones represent data, and computers use these zeros and ones to do computation. Since the 60s, we have been able to exponentially improve the efficiency and the size of computers. We went from vacuum tubes to the invention of transistors, and these transistors over time got really, really small, so we were able to invent microprocessors and microcontrollers, and what we have now that powers our computers. But there are some concerns over classical computers. There is a physical limit to how small a transistor can get, and we are close to getting to that threshold. Also, there are some problems that classical computers can't solve, or if they can, it's gonna take a long time, maybe years, decades, or even centuries. So this is where quantum computers come in. The problems that would take classical computers years, decades, or even centuries to solve, quantum computers can solve them in a matter of days or months. What's really the difference between classical computers and quantum computers? Quantum refers to really, really small particles, and these really small particles live in their own universe, which has its own physical laws. There are mainly two of these laws that interest us for quantum computing. One of them is superposition and the other one is entanglement. Superposition states that a particle can be in one or more states at a time, and entanglement says that particles are in constant communication regardless of the distance they are. So you can have a particle here and another one here, and they will still be able to communicate together. Or they can be here, close it to each other, and be able to communicate together. So distance isn't really what matters here. And because of these laws, quantum computers are able to solve problems faster and more efficiently. Quantum computers use qubits, so they are an equivalent of bits in the quantum computer world. So according to superposition, a qubit can be either a 0, a 1, or a combination of both at the same time. And since the particles are connected to each other, they can exchange data. So we said that quantum computers can perform computation faster and more efficiently than classical computers, potentially consume less energy as well. We also mentioned that they can solve problems faster than classical computers or even the most powerful supercomputer right now. But quantum computers do have some drawbacks, and the major drawback is sensitivity. Qubits are really sensitive particles. In the environment around the quantum computer, there are other in the environment around the quantum computer, there are also other particles that roam around. So for example, imagine this is your qubit in the quantum computer and you have other particles around. Sometimes these particles roam around and then they come into collision with other particles, and that can cause loss of data, which is not good for us because we don't want to lose data. We call this environmental noise or just noise. To reduce noise, some companies put their quantum computers in super cold environments. Since they are in super cold environments, there is not a lot of energy for other particles to move around. So you decrease the amount of interactions that qubit can have with outside particles. There are different approaches to build a quantum computer. For example, Google and IBM use the superconduction approach. Superconductivity allows for the creation of stable and controllable qubits by creating circuits and cooling them down to really, really low temperatures. There is also a photonic approach to building quantum computers. Photonics means use of photons or light particles, and you use light particles to do the computations. Xanadu, a quantum computing company located in Toronto, Canada, uses this approach, and they have recently published a paper about their new quantum computer, Aurora. So I'll link it below in the description so you can take a look for it yourself. There are also some other methods like trapped ion or diamond-based quantum computers, but I'm not gonna talk about them a lot. Photonics and superconduction are the main approaches to build quantum computers. As I mentioned before, because of their computational capabilities, quantum computers can tackle problems that would take current devices a really long time to solve. In his book Quantum Supremacy, Dr. Michio Kaku talks about the different applications of quantum computers in the real world. They can help discover new drugs because quantum computers are really good at simulation, so you can simulate different possibilities and come up with a new molecule or let's say protein. They can help to discover new drugs because quantum computers can simulate the molecular interactions with high precision, speeding up the development of new medication. They can also help creating new materials or help improving the current materials that we have. For example, right now the solar panels that we use aren't efficient. So imagine that we can create a new material for solar cells that will gather all or most of the light and convert it into electricity. This will be way more efficient and we can create more energy out of it. They can also help create stronger alloy. They can also help creating stronger alloys or advanced superconductors. And one other thing that they could possibly help us is in the artificial intelligence realm. They can even power artificial intelligence models by processing data sets and accelerating training times. There are many other applications, and I really recommend you reading this book because it talks about all the applications that quantum computers can have. I know I gave a lot of information and I talked a lot, but thank you to sticking until the end. I hope that this video was able to help you gain more knowledge about quantum computers. It is an area that interests me a lot, and I hope that I can work in this area in the future. It is still the early days for quantum computers, and there is even much more development that is needed for quantum computers to be truly revolutionizing. Thank you for watching this video, and until the next video, keep on learning more.